a couple meetups ago. She's the senior test engineer at Tally. She's been working at 7 years and has mentored several QA engineers, as I understand it. A lot. She's here to tell us about building automated testing for backend REST API.
Thank you, Ryan.
Thank you.
All right. Hello, everyone. So my name is Svetlana Levinsohn, or you can just call me Lana, it's easier. And I am a senior software development engineer in test at Tally. So a few words about myself. As Ryan mentioned, I have a lot of experience in test automation. I'm actually leading test automation efforts in Tally. And we pretty much automate everything. We automate mobile, web, APIs, and my favorite part, as you may guess, is actually API automation. I also work for one of the local QA schools where I teach a lot of classes, including API testing. So feel free to add me on LinkedIn. There is a link to my GitHub as well, my nickname, and we will be going over some code today. So all that code you can actually find on my GitHub. Just feel free to check it out. If you like something, take it. We actually today going to start very simple. We're going to talk about APIs. I would like to start with actually talking a little bit on what an API is and why is it important to test it. After that, we will jump to some coding tips and some good patterns that we actually inherit in Tally. But to start with, I hope most of you guys are actually familiar with this particular picture. In case you don't, most of the modern applications actually have client-server architecture, where we constantly have our application, our client side, which user usually interfaces with, exchanging data with the backend side, right, with the server side. So the abstraction that I actually like, the one that my mentor used to say a lot, is that the server side of our application is actually the brain of our application. Server side is where we usually build the logic of our application, right? And API is basically a tool that allows us to communicate, right? That allows us to basically communicate with the brain of our application. So this is extremely critical area, and this is something that you simply don't want to leave untested. We are going to be talking about REST today, and an average REST API call will look something like this. So in order to make an API call, you will need to make a request. You obviously have to provide some HTTP methods such as get, post, update, patch, whatever. You send it to a certain endpoint, and the server will be just listening to that endpoint and everything that's coming that way. You provide headers. You also provide a request body if needed, right? If you want to send some data to your server. Then server actually catches that and tries to fulfill your request, right? So server will provide us back with the response, and response will include status code, headers, and response body in case server sends us back some information. So in order to actually do the testing, we basically have to repeat this transaction, which is pretty obvious. So we have to make the request, then we get back the response, and we have to verify what we get back. So we have to make sure that status code is correct, that headers are fine, and if there is anything coming as a response body, we also have to check all the parameters and make sure that everything is there and everything is correct. We also want to check the time of this communication, simply because our users are not going to sit there and wait forever for response to API call to finish. So even over 1 second is usually too long. Another thing that we want to check here are things like, for example, permissions, right? If your user is trying to get some data, your user has to provide some sort of prove that this user actually has rights to view all this data, has enough permission. So it's going to be a token or a session ID. So you have to make sure that user is authorized, that we are providing data to somebody who have rights to view so. So all the API tests, I usually like to split into 2 categories. We usually test APIs by itself, where we just make one API call, verify that everything we get back is correct. And also we can do testing in like a sequence of calls. For example, you're trying to get user data. Let's say you're creating a user, you send post, created a user, then you're trying to get this user. If everything is correct, you're going to get 200 and user data. Everything's fine. But let's say you did post, then you did deleted this user. And after that, you're trying to get this user data, right? In this case, we would expect something like 404, and obviously no user should be provided. So when testing APIs, it is also critically important to test this action, like to test this sequence of calls. And this actually brings us to API automation. So for us in Tally, the sequence testing was basically the worst simply because we have a very long process of onboarding. So let's say we try to onboard our user, and for us, it's actually a sequence of more than 25 API calls. And now we want to build test automation in order to simply automate this test case so we don't have to repeat it manually. You can obviously test an API manually. You can use tools like Postman or PAW, just make the request, get back the response, make sure that everything you get back is correct. But now imagine that you have to do it 25 times for 25 different API calls. This is extremely long. Trust me, also extremely annoying and boring, but also there are a lot of room for actual human error, right? Simply because we basically send in this request and now we have to constantly verify that what we get back is correct, copy paste request bodies and things like this. This is a hell, right? So API automation actually helps us to avoid all these issues. So when building API automation, basically we want to build a suite of test cases that we can run every time we need. And we want to have some sort of ability to generate a report or artifact that would provide us with the results, right? So we can actually analyze what went wrong, what was good, and all the stakeholders can actually see it. So how are we going to do it? Today, I'm actually going to show you a very, very simple example. So what I did, I basically created some code with like some very basic things that we actually follow at Tally as well. And I'll just be walking you through this particular items, just showing you how to actually do this. We will be practicing and playing around with Swagger Pet Store APIs, which is basically their default set. And the very first example that I wanted to show to start with is let's actually try to create one automated test case that will be sending a request. It's going to be post request sent to this particular endpoint pet store API, and we're going to send it with a certain body, which is this top block. And then we need to obviously verify the response. So we're going to have to make sure that status code is 200, the response time is fast enough, and we get back the proper response body, which is what we see over here. So let's actually do it. I am going to show you an example. This is how it will look in Python and PyTest. And obviously, this is something like very straightforward. So what I'm doing here, I'm creating an object, this request body on top. And then I'm making an API call. I'm using the request library. I'm making a post API call to a certain endpoint. And I'm basically attaching this object as a payload. Obviously, at the end, to make sure that everything that our API works as expected, what I do, I'm verifying my response. So I get back the response, and I have to verify that status code is good, that time is okay, and also that I get back all the parameters that are expected. And this is extremely critical when you test APIs because every time you get something back, for example, if your application is expecting a parameter and it's no longer there, your application may potentially crash or something like this can happen. So for API testing, we actually have to verify that everything that we get back is correct and is there. So if we write a case like this, it will work for sure, but it's obviously not easy to maintain and simply not even easy to read without like my markers on top. So one of the first tips that I wanted to show you guys is actually how to get rid of this giant assertions on the bottom. So as you saw there, I was verifying that all the parameters I'm getting back are correct and they are there. So this kind of verification we can actually achieve with applying JSON schema. So what you can do, you can actually add a JSON schema into your code. In the JSON schema, you can define what properties your object should have. So what properties should be returned, data types as well, and what is required. So when you're doing the assertion, you can actually verify that your response matches what is defined in JSON schema. This is very convenient because let's say you need to make a change, you just make a change in the actual schema. You don't have to like go through tests and look for the places to fix things. Another thing that you can do, you can actually unify and separate the assertions to make them reusable. And this will lead us to something like this. So here you can see that it is a little bit easier to read the assertions. We also are more sure that everything we are doing is verified with the JSON schema. But still, it's not very good. Simply because imagine that now, let's say, instead of one API call, you actually want to make two API calls. And then it'll turn into this, right? So now we basically have the similar test case that will be making two API calls and verifying things at the end. So this is obviously not good, not optimal, simply because, first of all, the URL is hard-coded. Also, you're constantly repeating request, get, request, post, and you are doing it in order to basically do the same API calls. So what you can do here, you can actually separate the API calls into the steps. And this is one of the good practices that we kind of find very useful at Tally. And in order to do so, what we actually created is basically a separated client that will make all the API calls for you. So it's very convenient. And at the same time, you can also pull the actual API calls from the code of your tests into like reusable steps. So we call them steps, but basically it's like a separate directory where you can just keep the actual API calls and then reuse them every time you need it. Pretty convenient and also easy to maintain as well. Another thing we can do to improve our test case is actually take out the object generation from the actual code of the test. So you can put it in a separate step. And then as a result, the test case will look like this, right? So it's much easier to read. You can actually see what's happening. And moreover, every time you need to reuse something, you can just do it in a different test case and simply take it and reuse and maintain easily. Even with this approach though, sometimes I see people are getting into one pretty common mistake, and this is something like this. So very often I see that people who actually write API tests, they will create this giant API test case that will basically use all possible APIs that people want to verify. It'll be heavy on assertions in the middle. And as you may guess, it is not the best practice simply because, let's say your second get call is broken. Now the rest of your test case doesn't get executed, right? So you don't know if your put API is working, if your delete is working or not. So when thinking about API tests, still apply the best practices and try to make your tests atomic. So you actually want to break it into smaller tests. So your test suite can look like this. Basically, here I'm splitting the giant test into smaller tests for each particular API endpoint, and I'm verifying that all of them are working. Of course, there are cases where we have to actually test the whole sequence. We need to verify that our whole sequence is working. For those, you can also add another test, but I usually encourage people to also keep the separate, smaller ones, simply because it is more clear for us if something is broken, and we can find it with a small test much faster, and it is much easier. So those are the small tips for actual code of the tests. And another thing that I wanted to mention is don't forget that API test should also provide, API test automation should also provide you with some sort of artifact or some sort of report that you can actually review and then provide to your stakeholders. As an example, I'm using Allure over here. And the beauty of it is that you can just mark the steps or mark the features and the steps. And then when you actually running certain functions, each particular step will be pulled and generated in the report itself. So let me try to launch this and actually show you how it works. So here I'm basically running my final suite of test cases, 5 of them. And after that, I am generating the report using Allure. Let's see. It will look like this. And now we can actually look under each particular test case. And what we can see are the steps and everything that was happening during the test case, which is very convenient and super easy to read for both for you and for your developers or whoever is reviewing this report. So I hope this was helpful. Obviously, those are not all the things that you can do. Even us at Tally, we use more things to actually improve even this particular setting. But those were just a few tips to start with in order to build some suite for test automation of your APIs. And I hope they were helpful. Just to reiterate very quickly, test automation of the APIs is a very powerful and very important tool. For us and Tally, that was a very huge improvement to actually being confident in the releases that we are making. So now every time when we basically release or do some changes, we are absolutely sure that what we are releasing is not breaking whatever was built before. We are sure that we are delivering something and it is stable. It's very convenient because every time, for example, we work with APIs and we want to make an update, we build just a new version of the API. So all the existing tests, they still are working, right? If an existing if an existing test case breaks, it basically means there is a break, pretty much 99.9% of the cases, at least for us. And it's very simple and very quickly to basically see the areas where the break happens, just simply because of the report. And it's super easy to use. Our developers also have access to our reports. They have access to our jobs, and they can run test automation of the APIs every time they want to. And it's very, very convenient and visible for all the stakeholders what kind of results we're getting. So when building test automation for your APIs, don't forget, this is still in engineering, so apply the best practices. Make your framework scalable, separate your schemas, your API calls, your object generations from the code itself. Then also verify all the things. Verify status codes, verify all the whole payload that you are getting back, all the parameters, and test APIs by themselves in the sequence of calls as well. And also don't forget to utilize the reporting tool to make your test results visible and just readable for everyone. That's a great insight. So That's pretty much all I have today. In case you liked something, or in case this was helpful, feel free to check out this repo. It has all the code that I used. Thank you very much. If you have any questions, comments, or complaints, this is time to ask.
Do you actually use this API code to decrease time running your mobile automation framework?
That is a good question. So for mobile automation, we actually use API calls in the tests, but those are separate tests. They just use API calls. They don't use the tests.
So you just do not reuse this ones, you just write separate ones, right?
Basically.
Postman? Yes, Postman, yeah. We're moving to
Can I ask another one?
All right.
Sorry.
the GraphQL and gRPC.
When and how often do you actually run this API tests?
You said you're moving to which?
We actually run API tests against development. So developers, every time they make a change, they actually utilize this framework in order to make sure that everything is correct. We also run them in staging before we have to release. But from our experience, staging doesn't really find anything simply because everything got fixed in development, which is why it's basically super effective for us.
Okay. Yeah, sure as well.
My question was about that, like what environment? When you said development, is that a hermetic environment?
I'm sorry?
You said, I was going to ask what environment you use to run tests, and then you said the development environment. I'm guessing that's like a hermetic environment.
I mean,
So you built the service that you're testing, and then you're making the request.
Yes, that is a great question. So actually, our developers can also run those tests in their local environment too. But we as QA engineers, we usually actually work with development environment, which is not the local environment of developers, but where basically developers just merge their code originally before moving it to QA or staging.
Okay, but is this hermetic? Like when those API requests, are they actually like going across the network? Yeah. So that
Yes.
when you're measuring times, like how do you take into effect like latency and other external variables as well?
That is actually a good point. We have a different setting for different environments. So if it's something like development or local, we actually don't care about the time. But if it's staging, then we verify time because our staging is basically reflecting our production very well. So if staging is slow for us, it basically means that production is also going to be slow, and that's how we find the issues. So we basically don't verify time in development or local environments, but we test for response time in staging.
If you have a Swagger and spec, why do you need JSON schema on top of that? Can you use the JSON schema, the Swagger spec to validate the response body?
We actually don't use Swagger schemas at Tally, so that's why I'm sorry, we don't use Swagger specs, so that's why I am actually doing the JSON schemas. I'm pretty sure if we did, we would probably be able to hook it up together, but I'm not sure. I just use Swagger APIs in this presentation simply as an example because they have open APIs. That's it.
So like at Tally, how is your guys' API test automation integrated in your CI pipeline? Like, do you guys have it as kind of like a prep and check? Like, let's say someone pushes up like a Razor code and raises a PR, or let's say code is merged to master. Do you guys kind of run your API tests first as part of the CI pipeline before you run your E2E, or like which order, or do you run it in parallel?
Yeah, that is a great question. We are actually in the process of building the pipeline right now. So what we do is basically every time the developer pushes the code into dev environment, they actually go ahead and just run the Jenkins job in order to make sure that everything is fine. For UI automation, we just run nightly jobs. So they're kind of independent.
Okay, another question actually. So for the API test, I guess like how do you kind of like combat like flakiness of the API testing? Let's say like maybe like you're having like network issues, you can't really connect to the server, maybe like the server's down because of like your instance or whatever's being hosted on is down. Like does your API test cases kind of have like safety measures to kind of like report if it's like a network or a server issue? Or just going to report like a single failure and you have to like kind of dig in manually to see what's going wrong?
That is a very good question. So what happens upon failure? We actually get back status code and some body with the error that happened. And we actually group our test results in Allure by the error. So if that is the case, the minute you actually open Allure report, basically you'll see like 100 test cases failed because of, I don't know, 503 bad gateway timeout, right? So it's right away, it's very visible. And another thing that we actually did, we send this summary report from Allure to our Slack channel. And in that summary channel, we also outline the top failures. So if there is like the failure for like 500, we actually gonna see it in the Slack channel right away. So it means something is down. As far as flakiness, we don't really have a lot of it, simply because the tests are super stable.